This is a special report from About Space Today.
From Florida's Kennedy Space Center is Dawn Meyer.
Blue Origin's New Shepard rocket recently flew the deorbit, descent, and landing sensor demonstration with NASA's Space Technology Mission Directorate under a new tipping point partnership to test new precision lunar landing technologies. The Safe and Precise Landing Integrated Capabilities Evolution Project, or SPLICE for short, plans to develop, mature, demonstrate, and infuse precision landing and hazard avoidance technologies for NASA. This was the first payload to fly mounted on the exterior of a Blue Origin New Shepard booster rather than inside the capsule. It tested technology designed to achieve high-accuracy landing. This will enable long-term lunar exploration as well as future Mars missions. NASA Administrator Jim Bridenstine spoke of the importance of returning to the Moon and how Blue Origin suborbital experiments are helping NASA test the technologies.
It's critically important. So the way it's been for decades now is you have to go all the way to orbit the Earth. And of course, that's tremendously expensive to launch a rocket to the International Space Station, dock, and then do your experiments there. But if we could launch suborbitally and have maybe 5 to 10 minutes of microgravity where we can actually test technology and do training and do scientific experiments, and the fact that, we have these commercial providers like Blue Origin that can fly into suborbital space and help us test these technologies. It's an amazing relationship and, of course, critically important to accomplishing our mission.
Engineers at NASA and Blue Origin explain a little bit about the SPLICE Tipping Point project.
Tipping Point is a payload that we've been working together between Blue Origin and NASA, so it's really interesting collaboration. It's tied into the work that we're doing in terms of getting NASA and America back to the Moon.
So we're taking the best of NASA sensor developments across the agency, taking one or two commercial offerings, putting them on the propulsion module of New Shepard.
And what's really valuable with the propulsion module is coming all the way back from space and doing a propulsive landing, which is very akin to what we want to do with the lunar lander.
So we're replicating landing on the Moon using New Shepard.
We've generated maps of West Texas and put them into the terrain relative navigation software, so it'll be navigating relative to that. And we'll also then get this range and range rate from the LiDARs that we can compare to our GPS data.
This tipping point flight is a great showcase of the propulsion module as an active testbed for landing sensors.
This is really the first time that we've put payloads right on top of the booster. It's going to be fully exposed to space.
We want a way to land on the Moon regularly, autonomously, with higher precision.
We don't have GPS on the Moon, and not only do we require that same information, we also need to do it with much higher precision than we did in the Apollo days. Their landing target was on the order of miles. Our landing target is 100 meters or less. While we're descending through the surface at fairly high altitude, we're going to use the terrain relative navigation, kind of like a GPS.
By comparing images taken from a high-resolution camera to images stored on the onboard computer, we can know where we are relative to the lunar surface.
Then I switch over at a few kilometers above the surface to the LiDARs that are then going to be giving me range and range rate directly to the surface. This is technology that's been matured by NASA for, in some cases, 10 to 15 years. And so through this partnership, we can take those technologies, demonstrate them with the idea of infusing them into our future products.
And this particular experiment is going to help NASA land on the lunar surface faster, safer, and repeatedly.
Ariane Cornell, Director of Astronaut and Orbital Sales at Blue Origin, spoke with the technical lead for the NASA SPLICE experiment, Dr. John Carson, about how SPLICE works.
Why don't you walk us through your sensor experiment today and how it works?
So the system provides precise navigation information to a spacecraft that can be used for onboard that spacecraft for determining intelligent maneuvers that then can enable that spacecraft to land very precisely within half the distance of a football field roughly to the location that spacecraft is targeting for landing. So the sensors include multiple LiDAR, which are laser-based sensors a camera as well as something known as an inertial measurement unit.
We're testing this for lunar missions. Obviously, New Shepard for the moment is just going to be landing back here on Earth. How is working with a suborbital rocket helpful for your testing?
We've got a rich history of leveraging these platforms, which include not only rockets but also helicopters and aircraft and terrestrial flight platforms. We use these to go and test our integrated systems at conditions that are much closer to, the actual lunar or Mars or other landing trajectories than we can get just doing things in a lab. So that allows us to mature the systems, test them integrated together, and then, revise. We learn from these things. It allows us to revise the technologies, further improve on it, then go out and test it again and go right back to the labs.
Bigger picture, how do you see your sensor research and experiment today supporting other programs beyond the moon?
So they just kind of go back actually to the Apollo missions 50 years ago. So then they had to rely exclusively on the best processor and sensor that we have. That's the human mind and the human eye. So these LiDAR-based sensors, they're active sensors, they're able to see things that the human eye can't easily discern. For human missions, these sensors give that additional situational awareness that the human eye can't easily detect. So for robotic missions that do things fully autonomously, likewise, this gives those systems that kind of perception. And then we rely on advanced algorithms on that multi-core processing system to then detect those hazards and avoid them.
These are exciting times as we look toward the moon and ultimately Mars for future space exploration. From the Kennedy Space Center on Florida's Space Coast, this is Dawn Meyer for About Space Today.
This has been a special report from About Space Today.